My name is Liz, and welcome to our CRK Plus programming video. The CRK Plus is a driver with built-in programmable controller. It uses RS-485 multi-drop communications. It supports multiple motor frame sizes, and an encoder input is available for closed-loop functionality. The CRK is a 24-volt DC input system. What do customers need when using a CRK Plus? You need a CRK package, a CRK Plus package, which includes the motor and the driver with built-in controller. You need a 24-volt DC 2.5 amps or more power supply, as well as an RS-485 master or host controller. For PC users, you may need to source a converter, a USB to RS-485 or RS-232 to RS-485. Or if you have an RS-485 card, a converter is no longer needed. For PLC users, you'll need an RS-485 card. A terminal program for PC can be used such as HyperTerminal, TerraTerm, Absolute Telnet, and others. If a converter option is needed, please feel free to contact our technical support team for suggested converters, USB to RS-485 or RS-232 to RS-485. Also, when wiring your converter, please note the technical reference shown here. Depending on the cable end of 568A or 568B, we can see that pins 2 and 6 are opposites of each other depending on the cable end being used. I'd like to now introduce a basic motion profile example of an incremental motion. Here we can see the overall motion profile, and in this example we simply want to index a distance of 10,000 pulses. We have acceleration and deceleration time here set at 0.1 seconds each. Our starting velocity at Vs 100 Hz and Vr 1000 Hz, our running velocity. We have our distance, the overall distance of travel, being 10,000 pulses. Here we've assigned the general purpose outputs 3 and 4 as inactive, and we're looping by the count given by the variable of the letter Q. MI is for start moving incrementally, based on the distance that we previously set. Mend is wait for the motion to end and then send the value of PC, or the position counter. Output 4 is now set to active, and we're going to wait 1 second. Output 4 is now set to inactive, end the loop statement, and start to move to the absolute position of 0. Next is the mend, which is wait for the motion to end and send the PC value, or the position counter value. Output 3 is now set to active. Next, I'd like to introduce the CRK Plus programming example. Here we have an indexing conveyor application, so we need to know how to convert the overall application profile into a motion profile. So here we have to take into account the overall diameter pulley, which is 1.25 inches, and our motion profile is 25 inches in 5 seconds. We want to use 0.5 seconds for acceleration and deceleration time, and our goal is to use a 0.72 degree basic step angle motor, or a 500 steps per rev resolution. So to convert these values over to CRK Plus programming syntax, here we have to convert the overall move distance in revolutions. So we take our move distance, which is 25 inches, and divide it by the diameter, 1.25 inches, times pi. This gives us 6.366 revolutions. To convert this to the operating pulses, we take the overall revolutions and multiply it by the resolution of the motor, which is a 500 pulse per rev. This means we need 3,183 pulses to achieve that distance. So our DIS for distance is equal to 3,183 pulses. Next is our pulse speed. We have to take the operating number of pulses and divide it by the positioning time minus acceleration time. This is equal to 3,183 steps or pulses divided by 5 seconds, which is our total time, minus our acceleration time, which is 1 second. This is equal to 796 hertz. So our running velocity is 796 hertz. Next, we have to list our acceleration and deceleration time. Acceleration time, represented by TA, is equal to 0.5 seconds, and deceleration time, represented by TD, is equal to 0.5 seconds. Here we can see the overall CRK Plus programming example. We're going to create an infinite loop. If input 1 is high, move incrementally the given distance. Wait for 2 seconds and repeat this cycle. However, if input 2 is high, we're going to break the loop and end the program. Our syntax is as follows. Our DIS for the overall distance at 3,183 pulses. Acceleration and deceleration times, both set at 0.5 seconds. Our starting velocity, represented by Vs at 100 hertz, and our running velocity, Vr, represented at 796 hertz. We're going to create an infinite loop, so we're going to list our loop command, and we're going to create the condition. So if input 1 is 1 or high, we want to move incrementally the given distance above. Mend, which is wait for the motion to end, we're going to dwell for 2 seconds, end the if statement, and continue scanning. If input 2 is on, we're going to break the loop, end the if statement, end the loop, and end the program. Next, I'd like to show the motion profile timing chart for that example. Here we can see input 1, our motion, and input 2. As long as input 1 is on, the motion will continue to index the same amount, dwell 2 seconds, and continue indexing. This will continue until input 2 turns on. When input 2 turns on, the program ends. With the CRK Plus, we do offer the GUI Motion Creator software. It is available on our website to download. Now that we have a general overview on the programming, I'd like to introduce the CRK Plus demo. Please allow me a moment to switch to the demo. Today we'll be programming a dual axis system here. We have a 60 millimeter frame size CRK motor and a 42 millimeter frame size CRK motor, each with their respective drivers with built-in controllers, and these drivers are multi-dropped together via this cable up here, the RS-45, and I also have my RS-45 communication cable back here, which is connected to my PC via RS-232 to RS-45 converter. Today we'll be programming both axes. I'll be focusing on the 60 millimeter first, which is here represented as axis 0 on the software, and then axis 1, which is our 42 millimeter frame sizes. I'll also be introducing some global commands so that we can do the same motion profile on both motors. I'd now like to connect to desktop sharing. Please allow me a moment for desktop sharing to connect. So once you've downloaded the CRK Motion Creator software from our website, you can create a desktop icon as I have here. You have to select the proper COM port so that you can successfully connect to your CRK Plus system. In my case, it would be COM5. The COM ports do vary based on your PC, so just note that you connect to the correct COM port, you know that you are connected because at the bottom of the software shown here, you can see that you are connected to a device. On the Motion Creator tab, which is the very first tab shown here, we can see the number of IDs. As you saw in the demo, we do have 2 IDs, which we'll be taking a look at today. You have over here your motion type, where you can have an incremental motion, an absolute motion. You can move continuously in the positive or negative direction, or you can search for home in the positive or the negative direction. You have your motion parameters here, which are your basic motion parameters and overall distance. We can select a distance of 2,000 steps. We can see here on the syntax simulator window, as you type in these values, they will appear here. Our starting velocity can remain at 500. Our running velocity we can decrease to 2,000 pulses per second. Acceleration time, we can change that to 0.1 second, as well as deceleration time. Note that these values do show on the syntax simulator window. You're also able to create a start trigger if you'd like. The command position here is 0. The feedback position is also 0. Axis 0 does have an encoder, so we will be taking a look at the command position and the feedback position throughout the programming portion. You can also do alarm monitoring and the driver temperature monitoring. You have your start, your stop motion, and a hard stop. And at the very bottom here, you have your inputs and outputs. So we can go ahead and start a trigger and start the motion. The motion profile is completed, and we can now see the waveform capture chart. This chart can be saved or loaded. And here it draws out the overall motion profile. And we can now move on to the link indexing motion. Here, this allows you to link up to 4 motion profiles in the same direction. We can go ahead and change some of these values. So we can create a link motion with a velocity of 1,000, a distance of 2,000. The next motion we want to link is a 2,500 for our velocity and our total travel distance at 4,000 pulses. Next velocity is 3,000. Our distance, we can change it to 2,000. And our final motion at 4,500 for our velocity and at 5,000 for our distance. If you select the update, there's no start. You have to select where you want the link motion to start, and then you can check your boxes to link the motions together. So now if we select the update, it'll write down the actual programming syntax for this motion profile. We can also see the profile graph does have the motion profile as we desired based on our link motion. On the syntax simulator window, you can load this program from the PC onto the simulator window or save this program to the PC. We're going to go ahead and start our motion. And we can see that the motor did move these desired values. We can see the command position and the feedback position remain the same. Next is the program editor window. This window can be used to create and edit programs. You can save your programs, upload your programs, and download your programs to and from your CRK Plus. Here we have the online reference tools, which give you the syntax commands for the CRK to help with programming. It also has a brief description next to each command. The motion parameters, motion commands, link motion, program flow control, and so on. We can create a simple program here in the sequence editor. If you double click on the online reference, it will move it over to the sequence editor, and now you can type in your desired values. We're going to have a starting velocity at 100 Hertz, a running velocity at 1000 Hertz, acceleration time at 0.2 seconds, deceleration time at 0.2 seconds. We can have an incremental distance value of 2000 pulses, and we can select our motion command, move incremental. You can do a syntax check here by selecting the syntax check, and a message will pop up, no errors found. Renumber your lines and run your sequence editor. Run sequence now? Yes. And we can see we did move a distance of 2000 pulses. So note that right now our command position and our feedback position are at 17,000 pulses. I'm going to rerun this same program, and we should be at 19,000 pulses. On here, I'd also like to show the overall motion profile that we programmed via the indexing conveyor application that we took a look at before we did the desktop sharing here. So we'll renumber the lines and do a quick syntax check. At the bottom here are inputs and outputs, so please note that now we have a conditional statement. If input 1 is on, we'll move incrementally the given distance. Otherwise, if input 2 is on, break the loop system. So I'm going to go ahead and run the sequence editor. And please note down here at the bottom, inputs 1 and 2. I'm going to go ahead and activate input 1. And our motor is going to move incrementally the distance of 3,183 pulses, wait for 2 seconds, and continue the loop statement until I turn on input 2. I'm now going to go ahead and activate input 2. So input 1 is off, input 2 is off, and we can note that the motor is no longer in motion. Another example on the program editor screen is that you have your sequence directory. At the time of shipment, there is no program in your sequence directory. However, as you start storing your programs into your CRK Plus, they will all store here. These are some pre-programmed motion profiles. So we can take a look at a velocity change scan, which I have saved as number 4. You can select load to editor, you can save it to your PC, rename it, copy, delete, lock it or unlock it, run the sequence from the sequence directory, stop a sequence, or simply close. In our example, we want to load it to the editor screen. Here we can now see that what was there previously is now gone, and sequence 4 is now here. A velocity change scan. Starting velocity is 100 Hertz, running velocity is 2000 Hertz, acceleration and deceleration both set at 0.2 seconds, move continuously in the positive direction. Wait for 3 seconds, change the acceleration time to 0.5 seconds, and increase our run velocity to 4000 Hertz. Move continuous in the positive direction, wait for 5 seconds, and then abort the program. We can do a quick syntax check, no errors are found, and we can run the sequence editor screen. So we can now see that the motor did change in speed. I can go ahead and rerun that. Now we're going to go back to the sequence directory and take a look at a different program, a simple indexing motion. We'll load it to our editor screen. Now we can see the sequence editor has now sequence 5, which is a simple indexing motion. We're going to loop 8 times, a starting velocity of 100 Hz, a running velocity at 5,000 Hz, acceleration at 0.2 seconds, and deceleration at 0.1 second, a distance of 500 pulses, MI for move incrementally, mend, wait for the motion to end, wait 1 second, and then end the loop statement. We can do a syntax check, no errors are found, and run the sequence editor. Here, note the command and feedback positions. It's going to move a distance of 500 pulses at a time, 8 times. I can go ahead and rerun that sequence. We'll go back into the sequence directory and take a look at the final program here for the program editor window. It's a call subroutine. We'll load it to the editor. So sequence 6 is a call subroutine program based on a condition. If input 1 is high or 1, we're going to call sequence 4. Otherwise, or else, call sequence 5, end the if statement. So here we're going to go ahead and run this sequence, and I'll leave our input 1 as inactive. So it's going to call sequence 5. Sequence 5 was the indexing motion we just saw. So now we can see the motor's indexing by the given value of sequence 5. Now I'm going to go ahead and rerun that sequence with input 1 being 1. And it's now going to run sequence 4, which is a velocity change scan. On the program editor window, you're also able to upload and download all your sequences, so you can have some as backup. You can upload them or download them either to another CRK Plus or to the PC. The next tab over is the terminal window. Here in the terminal window, you can use the basic syntax commands that we show for the CRK Plus. I'm going to go ahead and type in report. Report is going to show us the overall I/O report, the parameter report, the position report, and the alarm history. You can also program via this page or run sequences. I'm going to list sequence 7. Sequence 7 is an ASCII return program. So what this sequence does is it loops 3 times and it changes the velocity, the running velocity. And each time the running velocity gets changed, it sends back the ASCII string speed change. So here we have VS as 100 Hz, VR as 1,000 Hz, acceleration time at 0.2 seconds, deceleration time at 0.1 second, move continuous in the positive direction while input 1 is off, when loop 3 times the running velocity is equal to the running velocity plus 1,000 hertz. Move continuous in the positive direction. SAS is the return ASCII string command, and we want it to return speed change. Wait 4 seconds, end loop, and abort. We can go ahead and run this sequence. You can type in run, and we know the sequence name is sequence 7. And select enter. So it's not doing a change in speed because while input 1 is 0, it's just going to run continuously in the positive direction at the given running velocity of 1,000. Once I turn input 1 on, you can note that it's changed speed 1 time, 2 times, and now 3 times because we put a loop for 3 times. Since we do have a dual access demo here, I can introduce the global command. The global command can use the @ symbol, and the access number at 1. This automatically changes us to this access 1. We can see the command position and feedback position at 0. If we want to go back to the original axis, which is axis 0, you type in at 0, and now we can see where motor 0 is at. For the value of 0, we're going to do an absolute motion of 0. So we want the motor to go back to 0, the commanded position of 0. Now, since we haven't commanded axis 1 to move, axis 1 is already at 0. The global commands can only be used in the immediate mode. They cannot be inserted into a program. So now we see the commanded position and the feedback position is 0, and I can introduce a global command, which is represented by the / MA 5000, so move to the absolute position of 5000. Both axis 0 and axis 1 will now go to the commanded position of 5000. So now we can see axis 0 is already at 5,000, and now we're going to check axis 1 by typing at 1, and we can also see that the command position is 5,000. Axis 1 does not have an encoder, therefore we do not have a feedback position. So we can now do an absolute position for 20,000, and with the global command, which is represented by that /, both of the motors will now go. So now we can see that axis 1 is at our commanded position of 20,000, and we can go back to axis 0, and we can also see that the command position and the feedback position are both 20,000. Next, I'd like to introduce our jog teach screen. This allows you to jog the motor as well as save the jog position as a desired position, which you can later use in programming. You can set the run velocity to your desired value. So in my case, I want to set it at 2,000. pulses per second. You can decide to move incremental one step at a time, as shown here in the command position and feedback position. Or you can jog it with the move continuous positive or negative. You can select save the current position, and it saves the position that I just had as position 1. You can select the View Delete Position Data, which gives you the positions that you have currently stored. You can store up to 64 positions for later use. And if you double click on them, they simply return to 0. Our final tab is the System Configuration tab, which are able to set your system parameters and do input and output assignments. Just be sure that if you do change a value on the system parameter or input and output, you want to make sure you save and reset. An output, we can set out 1 as run and out 2 as ready. Save and reset, we can see that it's resetting the controller and it's updating the data. Now we can see that out 2 is on because it's ready. We'll go back to the program editor screen here and run a program so that we can take a look at the input and output. We'll run the simple indexing motion, which is just going to loop 8 times, and we can see the outputs turn on and off. Output 1 is on because it's running. Once the program is ended, 1 will turn off and 2 will turn on because it's now ready. Please allow me a moment as I have to stop the desktop sharing. The CRK Plus is available in 3 different types of drivers. They're $357 each, available from 20 millimeters to 60 millimeter frame sizes. We offer gear types available as well: taper hob, planetary, harmonic, and harmonic gears. Encoder options are also available. If you have any questions, please feel free to contact us at 1-800-GO-BEXA or email us at techsupport@orientalmotor.com. My name is Liz, and thank you for watching our CRK Plus programming video.